And this is helpful for other places and other parts of Nova Scotia now that are just finding out they have HWA, or HWA is just right on the doorstep, like in Lunenburg County, and even some parts of Queens County. Property owners are just finding out they have HWA on the property. So first lesson, act quickly. Go to the next slide, please. So yeah, in 2017, HWA was found first of all in Weymouth area, and then was found very quickly in the next county, well, another county over, Yarmouth, and then was found in Annapolis, and we found out it was like 4 at that point counties, or 5 counties in 2017. And in the park, we breathed a sigh of relief for a little bit, thinking, oh, we don't have it yet. But we realized it had been in Nova Scotia probably for 10 years before, maybe even 15 years before, undetected. So that's a big lesson right there. Somehow HWA was in Nova Scotia and nobody noticed for quite a long time. And it's surprising now when you see it. If I'm driving along the road, I've got such an eye for it. I'm like, oh yeah, that tree's got it, that tree's got it, I can see it. But you have to be looking for it. And that's one thing with people are interacting with landowners. Don't assume they know what HWA is, they know how to say it, or even know what it looks like, because still in lots of areas, it's people don't have the search image and they don't know about it, and it's not even really on the radar. Even for those landowners who know what hemlock is, and have a pretty good idea of what they should be looking for, it's still not in common knowledge. So that was for us, finding out it was in Nova Scotia was a big shock. Next slide. Now, I'm from Kejimkujik, so a lot of the slides and everything I'll be talking about is from our area, our neck of the woods. We're the only National Historic Site, and it's also a national park. The whole of the park is a National Historic Site, and that's due to our ties, very close ties with the Mi'kmaq today and in the past. So, the whole cultural landscape of Kejimkujik is tied to hemlock. If you see hemlock along the portages, the campsites, the campground, a lot of that is hemlock. And it's a very important cultural, important species for Kejimkujik. But it also, with the invasive species, it also raises lots of questions. And anything we're going to do, we need to do that in a way that we were in agreement with the Mi'kmaq, because we can't just go ourselves, act quickly. Well, let's just do what we have to do. You have to talk about it, you have to learn, and that's what a big part of our project was about. Next slide.
Yeah, I don't know why it's not working.
Oh, there it goes. We skipped ahead though.
Yeah, I just went over it for a second.
Yeah, that one, yeah. The other thing about Kejimkujik at that time, we're going through a lot of changes, like everybody realizes in terms of climate change. The forest is also changing on its own, despite things like invasive species like Hemlock woolly Adelgid, and is actually interacting with that. So one of them is hurricanes, increased prevalence of hurricanes. Hurricane Dorian went through in 2019, impact on hemlock stands in Kejimkujik. It also, with climate change, we have warming temperatures, and HWA does better with warming temperatures. It's actually moving up faster than was predicted before, because it's really tied to those winter temperatures. If you have really cold winter temperatures, you're going to have a dieback of HWA that's going to get slower and slower in terms of its spread north. You can see that because if you go into a place like New Hampshire, which has hemlock, in the north part of the state, it's just reached northern New Hampshire. Same time it's reached Nova Scotia. That's kind of like, why? Well, it's because it's at higher elevation. The HWA is moving very slowly. It keeps getting killed by colder winters. Why it's not in New Brunswick? And it is in Nova Scotia. It's all temperature. It's not related to spread. It's probably HWA is probably getting there all the time and dying. Right? That's the thing they're finding out with the eDNA work, is they're finding eDNA in places where there is no HWA. Well, why? Probably because HWA is just not getting established. But it will, because you get a couple of warm winters and good conditions, and it will grow from there. Next slide. So we had a lot of invasive species, and that's the other thing that's kind of overwhelming to think about. Well, we got so much problems, especially around 2018. We had chain pickerel also be found in the park for the first time, so that's changing our aquatic ecosystems. We got this thing happening with Hemlock woolly Adelgid. we've had beach leaf mining weevil, which we're gonna see a lot more of prevalence right now, and I think there's especially in the general public, and even with a lot of ecologists, and some people just get overwhelmed and think, well, what can we do? Gotta throw up your hands and think, well, we might as well just give up. And you kind of think about, well, what are some of the other things that are coming through? Emerald ash borer is another one. So it's too many issues, too many problems, you get overwhelmed, and that's another factor which can prevent you from acting. Next slide. So we know eastern hemlock's an important species. You guys, a lot of people will be familiar with why it's important. It covers a lot of Kejimkujik, 9 to 10%, but then it's scattered throughout. It's a key component of our old growth forests in Nova Scotia. Has cooling effects along streams, key habitat for a lot of biodiversity, especially fungi, to keep the ears on the virtual line. And he's done lots of work on mushrooms in our hemlock forest, which is really important to catalog that. That's one thing we thought was cataloging what's in those forests before they really change too. It's very important also for carbon sequestration. Next slide. So hemlock woolly Adelgid, for those who don't know, it's native to Asia. There's lots of different native HWA in Asia, but it's not native to North America. It did make it on its own to BC. So we say non-native, but it's over thousands of years ago. It made it to BC on its own through the Bering Land Bridge. And with it came the predators that keep it in control. Problem with the East Coast is that we got HWA, but we didn't predators. So we have an unregulated population, and we also have eastern hemlock as opposed to western hemlock, which is totally defenseless against HWA. But they've done some experiments and realized even if you were to plant western hemlock here, it doesn't really, it's really the predators which control a hemlock woolly Adelgid. It's not the species, it's not resistant, it's more resistant. Hemlock, eastern or western hemlock is not more resistant than eastern hemlock. It's all the environment, the conditions that are there. There may be some differences in terms of how phenology is, but again, from the experts, some of the work that's been done, a lot of it is on, it's really the predators which keep HWA under control. So it was discovered in Kejimkujik in 2018, but it's been in eastern North America for a long time. 1950 it was reported in Virginia, but it might have been in eastern North America even 30 years before that. As I said before, it's not a really flashy species, and it's not killing trees, but some people don't really notice. So it kind of built up to a map where it started to kill a lot in the 1950s, and then rapidly it spread south, but then slower north. We expect about 90% hemlock mortality within 4 to 15 years. It can be even extended to 20 years in some places in the northern part of its range, but the trees definitely start to decline after sort of 7 years. Right now, we're seeing a lot of decline in Kejimkujik about 7 years after it was detected. Next slide. Why is there a problem? As I mentioned, no natural enemies, and it produces a lot of individuals. So that's a big sign of an invasive species is you have this unregulated population, doesn't have natural predators, and really the only thing that limits its population is food and the climate. Otherwise, it has unlimited potential to take over these trees. It just needs to get there, and the spread is not so fast compared to some other species, but it gets around pretty quick. And like I said, climate's really important. Next slide. This is a video of, but it won't work because it's a PDF, but it doesn't matter. This is the mobile stage. It's a coroller. And I think early on, we had a lot of discussion around spread and trying to reduce rates of spread. And really talking to the US guys, they were kind of like, sorry, Nova Scotia, you guys kind of have like the cat's out of the bag. You've got HWA all over the province. So trying to reduce the spread is really hard to try to contain it. In other areas, if you were to find an isolated pocket like they did in Toronto in just a couple of trees, you could cut the trees down and burn them. But we had a lot of discussions about, well, the campground, all these campers are underneath it, and they're going to be moving it everywhere. And I'm like, well, I don't know how important that is. We only have so much time, and are we going to spend it like scrubbing people's cars as they leave the park? I don't think so. And from what we could see of the spread, you could find HWA in places like Sporting Lake on an island which is visited by so few people. It's reaching there almost the same time as it's reaching, Kejimkujik. Well, how is that possible? It's because it's green bottom birds, wind, it gets around. Actually, the other day I was in Caledonia going by Paul Henderson's. You guys might not know where Paul lives. He's beside Brad. And there's one hemlock tree there. You don't see any hemlock around that tree, and it's covered with HWA. I'm like, how does it get there? It's just amazing. There's so many of those crawlers that millions and millions and millions in a forest that, of course, they get around and they get on things. Next slide. I won't go through the complicated life cycle, but they've got 2 life cycles, and they really are fast at this time. Right now, it's a very quick from the spring to the summer crawler stage where they're getting released. The adults grow very quickly through the instars, and then through the next stage, which is the cyst-in stage. The other one's called the progrediente stage. It's longer. You see over the winter, they do start growing again, but once they're settled in the summer, they actually have a period into the autumn where they don't do much. They're kind of like slow down and fall in a estivation, I guess is what it's called. And then they wake up. In the wintertime, they start feeding all winter. So at different times, it's really hard to find them. And that was the other thing that we did a lot at the beginning, was just trying to find these little tiny poppy seed Adelgids, and that's when they're in the nib stage. They don't have any of the wool. They're just tiny, smaller than a poppy seed. And imagine if there's only 1 or 2 of those on a branch in a whole forest, how hard that would be to find. And people are like, well, we gotta, cut down the branches. They're probably up there. And yeah, they could be there, but they also can be down below. It just depends on where the birds moved them or where the wind blew them. Finding out where it was helpful, but it didn't change a lot. Like it's still interesting to me how you can walk through a forest now and still see one tree covered and then another tree beside it with hardly any. And sometimes it's just confusing why it's distributed through the stand like that. And maybe it has something to do with particular trees are better at resisting it a little bit. It's not a lot known. And there are some trees which are resistant in the forest. They found that in the US as well, but they're not able to explain why. And it gets complicated to try to answer that question. They haven't found a genetic link to say, well, this tree is genetically different than this tree. So they're going to keep searching for that. And part of that is, I'll talk about that at the end, what we can do in the future. Next slide. So this gives you, it's a cool map just showing the spread. And like I mentioned, you still have parts of Vermont, New Hampshire, and Maine, which still don't have HWA. So it's definitely climate related, right? We're in the banana belt of Nova Scotia, and that's why we had HWA. Next slide. And that's showing the map, which USDA updates every year. They haven't updated for 25 yet, but Nova Scotia is looking pretty brown now, which is kind of sad. And you can see the whole range of hemlock is the green. So Ontario is the next stage, right? There's a lot of hemlock in through here. A lot of people are really concerned. And now HWA has moved north of the Lake Ontario. It's moving rapidly up along Michigan. So, they're in a much better situation than us, and they really did try to stop it in different places because a lot of the state is agricultural in the middle, and then they've got this really weird system of sand dunes with hemlock on the sand dunes. And so in a lot of parks along this edge, and then they were trying to stop it from moving up into this area, which is more like Ontario and has lots of hemlock mixed wood forest, but not too much left because it just keeps getting around some of the barriers they have, but they probably did slow it down somewhat. And in that case, some of the people are moving it, like some nursery stock is a really good way for a lot of invasive species to move because you're taking the whole tree, and the tree has HWA all over it, and you plant it somewhere else, and that's how it originally came to North America. Probably in a Japanese garden, someone had a hemlock tree from Japan, planted it, it had HWA on it, and it expanded from there. Next slide. So where are we right now in Nova Scotia? You can see it's now spread throughout Lunenburg, where there's a lot of hemlock, and it's in Halifax. There's another spot just north of Halifax now where it's been found. And I expect there'll keep being lots of observations around, north as you go from there to Toronto, because it's quite warm, just a matter of time. But you can see, I would say the line right now of really infested and declining trees is pretty much right where we are. It's certainly spotty. Some places are better than others, but if you go down to Shelburne, Yarmouth area, the trees are mostly dead. So there's some that are living, but the majority of the mortality has happened. And it is surprising how long some of the trees will survive and look really bad. So it's hard to say, hard to give up on them, but at some point something will get them, and they'll end up dying. I don't believe like we're gonna lose all our hemlock trees, because you can see in other places in the States where they still have hemlock trees. It's just that right now we're going through that really peak period of mortality, and then it will drop, and then we'll get probably another one, and it will slowly over the next 20 years or 30 years somewhat stabilize. Hopefully with the biocontrol, which will help more hemlock survive. Next slide. Yeah, so I said first lesson was act quickly, and the next one was don't panic, because I think some things take time. And at Kejimkujik, and with a lot of our partners, this is the first major outbreak in Canada. So there was a lot of differences between us and the US, and I'll talk a little bit about that, which meant we had to take our time and do things in a measured way. Next slide. Yeah, so this is some early pictures of us and the campground in 2018 when we found it there. Jeff Ogden is the provincial entomologist now, and with Celia Boone, she was the provincial entomologist at that point. We were trying to find out, where is it in the campground? We knew one volunteer from Friends of Keji found it, and then we were looking to see where it was, and it's now throughout the campground, of course, and then some areas where we found it initially the trees are really declining. And we have some mortality happening now. So that's 6 years later. Next slide. 7. So one of the ways to deal with a really big problem is break it to pieces. So this is our slide showing how we decided to really attack the problem, which is using this RAD format, which I think people have heard in relation to climate change more, but we used it for invasive species. So you can use this way of dividing up the problem. We couldn't protect all the hemlock trees. So we wanted to isolate the ones that we wanted to protect for sure, the highest priority ones, and those were our resist. That's our resist area, and that's the ones we use pesticide to keep the trees alive. And those are the high priority old growth stands that have multiple values, from Mi'kmaq, or could be for it's a heavily used visitor service site like the campground. Other areas we're just going to accept the trees are going to die. We can change, we can measure the change, do monitoring there, look at how the forest changes. That's important, but it's going to succeed into something else with a much more minor component of hemlock. And then direct is where you actually work to manage it in some way where you help transition the forest. And we did some of that in the campground area. We're hoping to move the forest from being purely hemlock stand into something that's more mixed wood. So we're doing a lot of planting and silviculture in those areas. Next slide. So the big one in terms of resist was these pesticides. And when we started in 2019, Imajet had just been approved, or it wasn't quite approved in Canada. So it was approved early on, and we brought up people from the States to show us how to use the equipment. And this is kind of showing what the stuff they brought up to show us. And it's like a needle that you would inject into a little plug you can put in the tree. You drill a hole, plug in, and inject the pesticide under pressure. And it's a systemic pesticide, so it goes throughout the whole tree. great if you've got 2 trees to do in your front yard. And that's how they make their money. This company, Arborjet, sells the mostly an arborist company. They sell to arborists and then they protect trees. And in the States, most of the pesticide that's applied is either with Cortex tablets, which are little tablets you put around the tree, have imidacloprid, and they over time degrade and go into the soil, or they have they often use Nalgene bottles of pesticide and just pour it around the tree. So that's in the US, they have very different regulations with pesticide, and it's often different depending on the state. So we talked to them, they said, oh, you do it this way. And I'm like, whoa, okay, we can't do it that way. We've got to look and see what we can do in our Canadian situation. So we had triazine, which is super expensive, not very, I think it's double or 3 times the cost of an imidacloprid often, and it doesn't last as long. Imidacloprid can last 5 to 7 years. Zytec did get approved over time, and that's a basal bark spray. And then we have dinotefuran now, which is also is approved but under emergency registration. I should say Zytec is also under emergency registration, but one of them, dinotefuran, will expire in 2025. It could be renewed, but to get all those things approved and to do some of the non-target impacts took a lot of work, and we needed to really do that with a lot of partners. So it took time. Next slide. So Imajet was the one early on chemical that was available. Its active ingredient is imidacloprid. So again, individual tree injection. It's not something you can spray from a plane or helicopter. So everything that's done with HWA is on an individual tree basis, and it's time consuming, but even for doing the basal bark spray, it takes time. So that affects how you're gonna manage the hemlock and what you can do. And you have to be realistic about that. And it's expensive, so it's not something that the average landowner, if you're thinking about treating more than a couple trees around your house, it gets pretty hard to think about treating multiple trees, especially if you're focused on what you get for value from the hemlock tree itself. You know, it doesn't equate. So it's a lot about values, and really talking to the landowner about that is important. It can be difficult conversations because people want to protect their trees, but the chemical is expensive. Zytec is cheaper and it's about the same price as the Starkle, but then you've got a different application using basal bark spray. And it's still expensive over time. Next slide. So this is showing us using, it's called the quick jet air, and it's again really good for using on individual trees. This is like the first tree we treated in Kejimkujik, I believe in 2020. And yeah, it's great to do that and feel good. I get one tree protected, but then you just look around, wow, we got a lot of trees. How's this gonna work? But next slide. Then we moved to a system where we used the canisters, and there was a number of individuals who got that going. Scott Robinson, Donna Crossland, and others figured out, well, we could use the trees, and these are used for the other chemical trees and to put into the tree, and they're little pressurized canisters. Well, you could put imidacloprid in them. Neither company likes that very much because they've got their own equipment they want you to use, and pretty much triazine said, don't use these things because we're not gonna, we don't validate the warranty, but it works really well, and it works great with volunteers too, because you can have lots of people with these canisters putting them into trees, and you don't have to sit there with the quick jet air and just wait until it goes in. You put them in, someone drills the holes, you put the canisters in, and then you move on to the other tree, and someone else comes around and strips them, takes off the canisters. So we did big areas of the park with that, and it was it's nice in the terms of the chemicals all contained within the tree. You're not spraying the areas. There's less transport of that spray, the chemical, to other areas around the tree. Next slide. So with all these questions about, well, what about a quicker method to do this using the basal bark spray? We needed to have a network we need to have people to help us do the research, and really that's how we built the HWA working group, which has a lot of different government organizations, non-government groups, MTRI is part of it. Right from the beginning, we had a lot of help from the US, as well as from academic institutions and Mi'kmaq organizations. And that's been a big strength of the finding invasive species and bringing people together to help figure out what to do. Next slide. So this is a slide, this is not really people from the network, but just I put this in because these are people from the campground that did some planting. And one thing you realize right away is how much people love hemlock trees, and people are willing to, help out, volunteer, do what they can to, save these trees, save these important, save the forest. And so it was easy, it's easy in some ways to get people interested in helping out. And that's been a big help in the US too. They have a lot of organizations which get volunteers, they get donations. People love hemlock trees. Next slide. So some of the research that we worked on with Kirk Hillyer's lab at Acadia and also with CFS. That's John Sweeney there with Corey as well from CFS doing the first basil bark treatments. Delbert there and Kyle. So there with the basil bark, it's Zytec 2F is sprayed onto the bottom of the tree, and then you follow up. We followed up to see how much Zytec was in the soil, but also how did it affect the invertebrates in the soil. Look to see if there was any impacts on pollinators as well. So next slide. And that information really helped to build these important documents, which allowed us to protect more trees. So one was a detailed impact assessment, which is a public document. You can get a copy of that, which allowed for not only the pesticide, but also the biocontrol. And then we also did an integrated pest management strategy, which has to be updated every year, which says what we're protecting, how we're doing it, and where it's happening. Next slide. Yeah, so that's Cody Chapman. He finished his master's last year, and did a work on the impact of the Zytec spray on invertebrates in the canopy and subcanopy. And he looked at control versus treated. Didn't find big impacts. There was one species of ant which was a little bit lower in the treated stands. It was significant, but of the other vertebrates, very little effects or no effects. There needs to be a bit more follow up on that, which is happening in Dr. Hillyer's lab to look at other soil invertebrates. Next slide. And we looked at pollinators as well, and bees, as well as flower flies. And although imidacloprid was found in some of the pollen, it was very low amounts, and there weren't any clear trends also between the treated or non-treated plots. That was Luca did that work. And there were some of you that know Luca because he worked here at MTRI, and he's still working with CFS now. So both of them are working on research papers. It should be coming up, we hope, pretty soon. It's in progress, but they're both done their thesis. Next slide. So there's work continuing on with this, and Kirk Hillyer right now has about $1.2 million over the next 3 years to look at more non-target impacts of the treatments on birds is one. He's working with CWS as well as CFS on others, non-target species like salamanders, also looking at other invertebrate and pollinators. So there's a big amount of work happening still on HWA and non-target impacts. Next slide. There's also work happening in Dr. Hillyer's lab on using eDNA. So this slide here shows, if you could see, there's like little slides on here, which aerial, I guess, would be eDNA falls on the slide, and then they analyze it to see if HWA is there. They've done not very helpful here, we know it's here, but they would do that in other places. Where they can look and see if they find HWA in spots in New Brunswick or in more northern Nova Scotia. But they're also looking to see if they find the biocontrols that we're releasing, because they're very hard to find. These beetles are tiny. You release them and then, okay, are they still here? Did they survive in the stand? And also look at native predators that already exist. And I'll talk a little bit more about that later. On that slide, you can have eDNA from these different biocontrols and native predators, and say whether they're present in the stand. And they're doing that in the US too. They're working together to kind of find more information out about it. And these traps you might see in the park or in other areas around, and that's looking at pine bark, Adelgid, and some of the Adelgid predators, which feed on HWA or feed on native, I'd say they're native predators, that would feed on pine bark Adelgid, also could switch to HWA. They don't expect them to make much of a difference, but they're kind of, they're similar to the species out west that we bring to be more specialized. So we want to know more about what are the species that are currently here. I'll talk a little bit more about that later. Next slide. Yeah, so I talked a lot about the people from the US. This is from a picture last year, which was taken in the park. We had over 60 people in Liverpool. Crystal was there. It was a great event. Lots of learning, and a lot of the programs that are happening in the US have been going on for many years, so there's been lots of information, and yeah, it was great to have them up in Liverpool and learn about what's going on up here in Canada. So it was a good event, and there's a lot of learning going back and forth between these areas. So if you have questions about what might work in Canada, you know, there's probably been tried in the US, and there could be some good learning there. Next slide. Yeah, so that kind of brings me to another point, which is just like learning from other voices and perspectives. This is a really important one. We did lots of learning from other groups in the US. Next slide. But one of the most important was just having the Mi'kmaq groups as part of the working group right from the very beginning. And so one thing that helped with this whole having trees being treated in the park, having biocontrols released, was that at the same time we were learning about it, we were learning with the Mi'kmaq at the same time. So someone like Sherilyn Young became a big proponent of, oh, we need to protect these trees, because she was on the same, like we're all learning the same thing, and she was asking questions. Okay, well, what about this? What about that? We were asking her to review stuff in a way where we were ready to use the information she was giving us. We were like, okay, well, that's something we hadn't thought about. Or she was very concerned, and she heard a lot from the Mi'kmaq community's concern about the pesticides going into the water. So having buffers around the water was very important for the basal bark spray. And a place like Acidulis, which you guys are, I'm sure, really familiar, they've treated lots of trees there now. That wouldn't have been possible, I don't think, without early, really talking about co-management in Kejimkujik, but also co-development of the projects. And in their forest, they made the decision, we're only gonna do stem injection. You're not gonna do any basal bark spray. So that's a value for them. It's like, we don't want to have basal bark spray because it's definitely has a higher potential for it to impact other species. And it could get into water more likely. So using a really precautionary approach, decided just to do stem injection. And that's their own values for sure, and what they see as being really important. So that was part of the working group too, is you have people coming up from different perspectives. And there were people also a few people that were like, okay, I'm not interested in treating at all. Well, you can also be part of the group, but looking at how Hemlock woolly Adelgid is going to change the forest over time. I don't think we were trying to keep it pretty big tent in terms of listening to all different perspectives, which I think is important, because sometimes with invasive species, you find just one group might be just the entomologists that are focused on the bugs and how to kill the bugs. And not to put people down from CFS, but that's often how it works, like spruce bug run. How do we get, they're not thinking necessarily about all the other parts, the ecology. And Hemlock's great because there's so much importance for those species, for old growth forests, for other species. So bringing people together with different viewpoints, I think, made it a stronger project in the end. Next slide. Yeah, so making a plan and sticking with it, and that's hard. I think I tried to, wasn't sure if there's gonna be any landowners here. I know Abby will be talking to, other people will be talking to landowners, and that's the hardest part with this HWA thing. And I was talking to past superintendent of the park last night. I went by his property, Harry DeLong. He has 20 acres of property, trying to figure out how to do. It's got some HWA in it, and it's hard because it's not as easy as just going to the hardware store and picking up some pesticide, which you might in the US, and pouring it around a tree. You gotta have equipment, you gotta know how to calculate how much you should apply to the tree, you need to have a pesticide applicator's license. There's a lot of steps, and there's people that can help you, but it's not always clear. So I think we're still struggling a little bit with that. There's different groups like MCFC, who do provide lots of support, and MTRI provides support. But, it's, when you think about all the landowners in Lunenburg County and Queens County that have HWA, that's a lot of people. It needs to be a program that deals with this, because a lot of people are just, they're not getting the information, or they're struggling to find the information. But making a plan, mapping out the forest, finding out which trees to map to do was a big part of the plan at Kejimkujik. Next slide. So this shows the number of trees we treated over time. So I think we're now at over 6,000 trees, including the spring treatment. So probably 250,000 DBH centimeters of trees and 14 different stands. A lot of it's been in stem injection, but we're starting to do more basal dark spray. Next slide. Yeah, so this would be like 1 year of treatment, 2024. It's hard, like some of these stands, like Frozen Ocean, these are trees around a campsite. It's a nice stand, site 4, I think site 5, and 4 maybe, there's a couple there. Just to get out to the site, to do the treatments, takes quite a bit of time. You get there, you gotta do that might only take 1 or 2 days, but to get out there and get all the equipment there takes time, and that's, the province has treated thousands of trees now in lots of different stands, and some of them are quite remote. It's a lot of work, and it's not always just about the numbers. We're trying to find the priority stands and do those. That's what we've done. A lot of Hemlock's priorities, and the other is JPC, which is the campground. We've treated quite a bit in the campground because it's an important site for visitors. And we know if we don't treat them, we're gonna have a lot of trees dying. How do we deal with hazard trees? Next slide. Yeah, so just Dennis Boot. Your dad was out there, yeah, quite an experience.
See a photo like this.
Yeah, well, this is their camp. This is their camp at night. Yeah, they camped out there for I think it was 2 weeks. About that. Unbelievable risk, really, to get everybody out there with helicopters, pesticide. I say risk because it's also hurricane season, and we had to kind of like wrap it up and get everybody out of there because we were worried about a hurricane coming and getting people trapped out there. We were doing extra trees at that point. They were so efficient, but that was done, led by Scott Robinson, but it was a lot of logistics to get out there and treat that stand. Next year is 5 years since it's been treated. So yeah, that's the planned part, right? Now you have to start retreating. And if you treated too much to begin with, and now you gotta retreat them 5 years later, do you have the money? Do you have the staff? All that is a big issue. And I, like, as a private landowner who's treated trees too, I think about that, because I go treat stands and I go, well, in 5 years, am I gonna be able to retreat it? We'll have the money. I don't wanna do everything and then, not be able to help them in the past, help them in the future. So yeah, this was the base camp at night. Operation to get up there. The helicopter was landing on a rock, probably, it was maybe 10 by 10 size to let people out on the side of this lake, and we use this, slung a lot of the food and all the gear into a little hole in the canopy. And, yeah, we got 1,200 trees treated there. So we gotta go back and, retreat that next year. We'll see how that goes. It's gonna be a challenge. Next slide. Yeah, so we also do, and I think some people might say, oh, why aren't you treating more trees? But we do a lot of other parts as part of the HWH work. Some of that's research, but it's also monitoring. We monitor the water to look at the midchloride. We do tree planting. We've done soil samples. We've done work with Keith and on fungi. Lots of different other aspects than just treatments. We have a pretty broad program. And part of that is also monitoring canopy health over time to look at how the trees are doing in the stands we didn't treat. Next slide. Yeah, so also have a plan, but also be adaptive. You gotta take risks and try different things, because I think, like I said, with Hemlock and the whole problem, there's not one clear, this is the best thing to do. There's a lot of, you put all your eggs in one basket, it may find yourself in a tough spot in terms of treatment. So we did do some other different types of work, and one of those is doing silviculture. Next slide. Yeah, so we worked with MCFC to do some silviculture on the campground, and this was really to take out, because it was a relatively young stand. You treat every tree, over time, those trees are gonna also self-thin. So does it make sense to treat every tree? So we worked with them to do some thinning, and the trees that are left, we hope those trees do better because they have more sunlight, they're gonna compete better. Also some evidence that sunlight, the HWA doesn't like sunlight, the numbers might be lower, and if we treat them, hey, maybe the tree will be even better. So we did work with Mary Jane and then later Matt on the silviculture project, where we moved 20% of the eastern hemlock across an area of 30 hectares, to really taking out declining and diseased, otherwise damaged trees. Next slide. So we did that some with our own staff, which was these orange areas, and then the green areas were what we were hoping to get done the following year with a contractor. In the end, we just got this yellow part done, so we're hoping to get another section done. Took more time than we were thinking. Part of it is just running up against weather, trying to get it done before you got snow. We didn't want to have big ruts, of course. And we used a really low impact way of doing the cutting. Next slide. So this was done with a company from Truro, really small equipment. Next slide. Yeah, it's hard to see, but this is like a really tiny little forwarder. Next slide. And then we did planting in those areas that were opened up in terms of sun. So we've done a lot of planting of oak and sugar maple. Next slide. Oh, that's the end.
It's black here.
Next slide.
There.
Okay, maybe the other part which is adaptive is biocontrol. So I think people get excited when they hear about it, and they're always asking, so do you have the bugs? It's a drug that's gonna fix everything, right? It's like, no, yeah, we have some bugs in the park. And good news is they've done some eDNA testing. They found eDNA from the biocontrol that released. So that means they're reproducing and they're surviving in Nova Scotia, and they eat only HWA. So the Laricobius nigrinus is doing well, and hopefully it's growing in numbers. But it's a really long-term strategy. And, those beetles were brought from BC and released by CFS, and they're doing well, which is great news. And they released 5,000 the first year across a big area of southwest Nova Scotia. So over time, they will expand and help to control HWA. But if you talk to them, it's a decades kind of situation. It's not immediate, and it will take time for their numbers to grow. Next slide. So the biocontrols, Laricobius nigrinus, this is the one we released in the park, and it really eats HWA during the winter period of time and is active during one life cycle, the cystin generation, but not the progredion generation. So they're hoping to bring in some other biocontrol, the silverfly, which will help control the other generation. But at this point, it's a little more trickier to rear. You can't just bring them from West Coast. You need to grow them in a lab. So Kirk is working on that and working with the folks from the States, Mark Whitmore-ish, who has really provided a lot of feedback on that, how to do that. And they're releasing them in the US now. We're also looking at other species to release. As one of them is Adelgid osakensis, which is originally from Japan. So it's not a North American species like the Laricobius nigrinus, but it's been released a lot in the US, and there's some benefits to using osakensis. So they are looking to make some releases in Nova Scotia, but it will take a bit more time to do some of the research and look at the US results to make sure there's no non-target impacts. Next slide. Yeah, so there's some slides from the US. I've been lucky enough to travel down there a couple times to see what they're doing there, and this was from a lab in Virginia where they collect the foliage with some of those predators already in there, and then they rear them and then release them in Eastern North America. Next slide. Yeah, so my final thing is just to keep calm and carry on. It's not it's a difficult thing working with Hemlock, woolly Adelgid, and a lot of people, I'm sure in this room and online, they really care about Hemlock forests, and it's hard to see them declining. It's hard to see the ecosystem changing, but there are some signs of hope amidst a lot of the gloom. Next slide. So this is, again, it's hard to see it online, but this is Mill Falls. So you can see already now the trees are really starting to decline there. If you visit the area, you can see how the trees look like they're a bit burnt on the edges. And right along the edge of the forest, right on the edge of the river, we did treat those trees, but they're on rock. So they really are sensitive, I think, to HWA, and they're starting to decline. But behind it, the trees have all been treated and they're looking much better. Next slide, that's looking at it downstream again. So you're starting to see them look a little bit grayer, which is sad. Things will, there's quite a bit of pine in that stand too, so it will transition a bit, but some of the hemlock further from the river seem to be doing better. Next slide. Yeah, this was hard to see. I went down the Shelburne River this spring. So this is Pollard's Falls. Next slide. It's an incredible old growth forest, and a lot of those trees are dead now. So they're falling. You see the size of that tree. There's a canoe there. It's a giant trees. Though not everything's going to be able to be protected, and there are some that are further away from the river that were treated. But these ones were already really quite infested in 2018 or 2019 when some of the first treatments happened. Next slide. Yeah, so this is the hope. This is in the campground now, in the place where we had HWA the first, it was found in 2018. There are some trees there that have been treated the longest, and this is one here showing how great that canopy looks. And that's what we're seeing now, is trees that were treated 3 years ago. As the other stands are declining so much faster now, you really are seeing a difference between the treated and untreated trees. So that is good news. I think early on when you treat trees, it's kind of you're hoping that will be the what happens, but it's hard to see, especially if you've got trees that are in relatively good shape. But now in the park, we are seeing a lot of declining hemlock, so the difference is very distinct. And it's good news to see those trees doing so well. And yeah, they'll be up for retreatment in a year or two, and they'll should go on living, and you have a great example of hemlock in some of these treated stands. Next slide. Yeah, this is pictures from Virginia, which has had HWA for a very long time. It's also hopeful to go there and see what's going on. So these are hemlock trees there. So they've had HWA in the late nineties, and they had massive die-off of hemlock very quickly because it's so warm. So they did treat a fair number of trees as fast as they could, and some of those trees did have survived. You can see this one here has a tag on it, and so from discussions with the people there, it might have been treated 3 times, and then they stopped treating. So at this point, there's already biocontrol in the ecosystem. There's still HWA, of course, it's not disappeared, but it's more in balance with the native, not native, but now the biocontrol that's established in these areas. In a lot of spots in the States now, you can find those Laricobius nigrinus in the stand. There's still lots of HWA, and it's not all, it goes up and down, of course, in different areas, but it was still remarkable to see those trees doing so well in an area which has had HWA for so long. Next slide. Yeah, so this is another hemlock from down in Virginia area that was also doing quite well, and they're not treating as many in that forest, and the trees are looking pretty good, which is a good sign. Next slide. I think that might be it. Yeah, so that's sort of an overview, some advice, or some thoughts on the last 7 years of HWA. The MTRI has been a great help with a lot of the early conversations, what do we do, and highlighting the importance of doing something to protect hemlock trees and helping with the research. So thanks again to MTRI for having me to speak. And yeah, I'd be open for any questions. For a while.